Uh, Welcome everyone, and thank you all for joining for the last presentation I'll be doing at the SIP seminar series this year. Like all the other presentations, everyone hopefully will stay muted by default, but feel free to ask questions along the way in the chat if you have any, and I'll take time to answer any sort of questions at the end of this presentation as well. So today's presentation is going to be about automating your Qualtrics to Lava pipeline using R. It's very much tailored to kind of the clinical research coordinator job duties, particularly when it comes to transferring data from Qualtrics to Lava, if that's something that you find yourself doing frequently. The end goal of this presentation, of course, is that you can automate most of that process and free up time to engage in other activities, while also creating kind of a systematic way of transferring your team's data such that successors to your position can maintain workflow continuity and have an easily set up system to continue doing the work that you do. So in order to understand the process at hand, we'll first need to discuss the Qualtrics API, or more generally, what an API is. So with that, what is an API? Well, if you Google it, you get a bunch of cute little photos giving a diagram of an API, computers, and other stuff, so to speak. And some of these images are simple, some detailed, some useful, and some not really useful. But what I like about them is they all ultimately represent a singular idea that I think is kind of clearly represented in this final photo. And that is that an API is essentially an interface between a computer, presumably your computer, and some other set of information or a database that's elsewhere in the ether, the internet. And this idea of interfacing is baked right into the name. API stands for Application Programming Interface. And here's the Oxford Dictionary definition of it, which I think is a bit obtuse, but it basically means that something, an API, helps two very different systems talk to and interface with one another. And I think this idea is best illustrated with maybe an everyday example that you would see when you're using the internet. So if you've ever gone to a website that asks you to make an account with them, you've probably seen the option that allows you to sign up with your Google or Facebook or LinkedIn or a Twitter account maybe, kind of demonstrated with the image you see on the left here. And so if you use those kind of links to sign up for a different type of website, those websites don't actually take your login information and store your password, because that's a really big big security risk. So instead, when you use those links, you're using Facebook to log in or sign up for a website. You're actually allowing the website you're on to check that you're already logged into Facebook, for example, and then the website sends a request to Facebook for the information it wants from your Facebook profile, like your name, age, gender, phone number, and so on. And that info is returned from Facebook's API in a relatively standard format that lets the requesting website easily parse out the data, so all the info about your name, age, and so on fills in the right spaces in that website's database. So at the core, what I've described here, or what's happened, is that one website asked for neatly formatted information from another website. And that's really all that an API allows or kind of enables. So I think the next question here is really, how does website A actually make the request for data from website B? And the way that's done is using what's called HTTP. It's a language that means Hypertext Transfer Protocol. It should be a little bit familiar to some of you actually already. So in fact, your computer interfaces with websites using HTTP, or more recently, the HTTPS or secure version of it. So you see it every time you type a web link into your address bar in Google Chrome or whatever browser you use. And it actually means you're submitting a Hypertext Transfer Protocol request to a web address so you can see the website and whatever website you want to go to in all of its beauty. And it's a standardized language for communication between web browsers, computers, servers. It's useful because it provides this standard set of information or way to request information from websites that might have their data structured in different ways. And the details of how HTTP works are otherwise irrelevant for this discussion of the Qualtrics API. But I think it's good to understand that every time you want to log into a site or pull data programmatically from somewhere, it almost certainly relies on an HTTP request. And so unsurprisingly, Qualtrics has an API. And like other APIs, theirs allows you to request data. And their API more specifically allows you to request and download all of the data stored in your Qualtrics account. And when I talk about the data in your account, I think what people are really going to care about here is the data from your surveys. So what this means, this ability to download survey data from the Qualtrics API means that you don't need to log into Qualtrics and manually download data anymore. The API essentially allows you to automate this download process, and ideally any sort of cleaning steps, and it can all be neatly packaged into a single coding script. And as a kind of a cherry on top of this, someone actually wrote a package in R that takes care of all of the HTTP work and the API programming issues, and just lets us run a couple of simple R commands. In fact, there are about 3 total functions, just 3, that you'll need to learn in order to get your data from Qualtrics in kind of a nice data frame format that looks like a CSV file. But before we get into that, I want to talk a little bit about why you should care about automating this process. So to begin with, automating this, it's just faster. And it's more convenient to press a single button that will download all of your data whenever you want to get it downloaded. Moreover, writing a script that will download your data in kind of a repeated, reproducible manner will greatly reduce the risk of making mistakes in the download and cleaning process. So you won't have to troubleshoot any sort of issues once you have everything set up the first time. And because I know everyone here at the Mac is great at writing SOPs, doing this, creating a script that will automate the download and cleaning process kind of automates this, this SOP making procedure. And it allows for a clear and consistent procedure that can be passed along to future staff. And in essence, the code that you would write to download and clean this data, if you add in a couple of additional notes to it, it also really does serve as documentation of the process to get your data from Qualtrics over to Lava or maybe wherever else your data is being moved to. But it is both doing the work for you, and it serves almost as an SOP, as I think one of the other major advantages here. So when it comes to the Qualtrics API, I think the next question is, what can we automate? And like I've mentioned, you can automate the download of the data. You can also you can also automate any sort of data cleaning steps. If you have more intermediate R skills, you might know how to do some of the data filtering procedures or other calculations that you would want to do with your data. And then finally, what I think people find themselves doing pretty frequently with data that's moving from Qualtrics to Lava is renaming some of the columns, and in particular, adding the skip label to column names. And that's something that can also be automated without really any sort of risk of doing things incorrectly. So what can't we automate? We can't automate any sort of changes that you might make to the survey. So any sort of adjustments, if you take questions away, add new questions to a survey, you should keep in mind that the script you've written should be updated to reflect changes, and you should kind of test that out before you try to move Qualtrics data over to Lava. And the other thing that hasn't been fully automated yet, unfortunately, is the ability to actually send the data into Lava. But fortunately, if you're someone who's already set up Lava import definitions or the Lava import tools, none of this will, you'll need to do it. You'll need to upload the data technically by hand, but you can drop an entire spreadsheet into Lava all at once. And it takes just a couple of minutes. So with that, we'll kind of jump into the process of getting everything set up. So first, what will you need? Unsurprisingly, you'll need the R software, and I always recommend that people use RStudio. You'll want to download these 3 packages listed here. I've talked about both the tidyverse package and the keyringer package in previous presentations. The tidyverse is mostly just a set of packages that allow you to easily clean and set up some of your data. And the keyringer package is used to access passwords that are stored in your password keychain. And we'll talk about those a little bit later. And the Qualtrics package, which I had mentioned previously, is a package that someone wrote that specifically interfaces with Qualtrics API. So we don't need to know how to write any sort of HTTP code requests. All the heavy lifting has already been done for you. And then finally, I always encourage people to use Git and GitHub to track any sort of changes that might happen in their scripts. I would particularly encourage using a version control system for scripts like this that will be managing data. So there's always a history of how your data was managed in the past. So assuming you have all of these, all the software and packages installed in your computer already, what do we do? So there are three major steps. The first one is getting your Qualtrics API token set up. And if you're not familiar, a token is essentially another name for a password, except it's a very long, randomly generated code made by the website you're using, and it's linked to your specific account. So you should never share it with anyone. It's actually more powerful than a password because you really only need the token. Whereas if you're regularly signing into a website, you would both need a password and a username. From there, I'll show you how to use our code and the Qualtrics API package, or sorry, the API token to download data from Qualtrics. And then finally, I'll show you how to do some common data frame manipulation and data cleaning that you'll want to accomplish before uploading your data to Lava. So in the first step, setting up the Qualtrics API token, it's really comprised of two steps. The first is finding your API token in your Qualtrics account, and then storing the API token in your password manager. So let's go ahead and watch a short clip that demonstrates both of these steps together. So you see here, I'm just in the kind of normal UCSF Qualtrics web page. You want to go to that top right corner and press the little person button followed by account settings. And from there, you want to click the Qualtrics IDs tab. Once this gets opened, you'll go over to the right side, and under this label API, you'll see token. We want to copy this value, and we want to move this value and store it over in our keychain, which is the, on Mac at least, it's kind of the computer's inbuilt password manager. So I'll go ahead and press the plus button to add it. We want to give a descriptive label here. In this case, I'm calling it the Qualtrics API token. Then I just give a quick description below for the account name, and you paste that token into the password section. And in this case, I'm going to go ahead and add the underscore test just so I know to remove this one later. And with that, we've found our Qualtrics API token, and we've added it to our password manager. So once you have that set up, we want to leverage some R code and the API token to actually download the data. And this process can be split into three steps. The first is that you need to authenticate your computer. And you do this by running the Qualtrics API credentials command from that Qualtrics package that I had talked about. And you'll see highlighted in yellow that we're using a function called decrypt keychain, or KCPW, which is pulling our Qualtrics API token from the computer password manager. And you also see highlighted in blue that there's a link listed under the base URL argument. You want to copy that web address exactly as you see it on my screen, because that's the kind of the web address that will direct your Qualtrics API credential kind of authentication request to the UCSF version of Qualtrics. So if you were working at another institution, say UCLA, presumably their base URL would be something like ucla.co1.qualtrics.com and so on. And after you run this function, you can press Command Return in the R when you're running this function in R, and you'll be prompted to access the keychain, which means you just need to enter your computer password. And once you've done that, after your computer is authenticated, you'll want to pull a list of the surveys currently available in your Qualtrics library. And you can do this just by simply running the all_surveys command. And in this case, I've also written this %greater than %view function. And what this does is it'll just pull up all of the surveys, the entire kind of data frame of surveys in a really nice and easy format to look at. And then once you've gone through that list of surveys and you've identified the survey for which you want data, you can run the fetch survey function where you specify the survey ID that you want to download the survey for. And I haven't talked about the survey ID yet, but I'll show you what it looks like in the video. So in this case, there are a couple of workflow elements going on here. If you're trying to write a script to automate this process, you want to make sure that these three packages are loaded: the tidyverse, the Qualtrics package, and Keyringer. And you want to go ahead and run all those lines so that the libraries are actually loaded. And from there, you can go ahead and type out this Qualtrics API credentials function. And you want to say the API key is equal to this decrypt KC password that we had talked about. And you'll, within quotes, you'll want to specifically write the name of the keychain password, or sorry, keychain label that we gave. So in this case, it was Qualtrics API token test. And then, as I mentioned earlier, there's also this base URL that you want to specify. So when you try to run this function, like I said, you're prompted to enter your computer password. Frequently, it will ask you to do it twice. And I don't get any sort of error message, which means that my computer is all good to go. So we want to go ahead and take a look at what surveys I have available in my account. So we type this all surveys function, and then I want to view the results of that. And as you can see, there are a large number of surveys in my account, and there are just a couple of variables. We have this ID and name variable, these first two columns, and these are what we really care about. And in this case, I want to go for a survey that doesn't have any sort of patient identification. So we're going with this MRI eye tracking one. And I copy that ID, that first column, because that's the survey ID that we'll need in the fetch survey function. So go ahead and write out fetch survey. And we want to enter survey ID equals, and then you want to write quotes and paste in the survey ID of the survey that you want to draw data for. And finally, there's this force request equals true. You don't need to worry about the details of that, but basically it means that we'll get a fresh survey. It'll actually make sure we ask Qualtrics for fresh data every time. So we run that, and you'll see we have a data frame. It's pulled all the data from that survey that I had talked about earlier just by using this the survey ID that I copied and pasted in. So there are a couple of things I want to note about that quickly. I want to quickly talk about the output method of the data when we use this API kind of request. So if you've ever exported data from Qualtrics, you probably know that you can either get output that is the exact text or choice text version of the data, or you can get the underlying numbers or numeric output. The format of the data is kind of going to be, at your own group's discretion. But what I do want to say is that, the default format or the code that I showed you in the previous example will give you the choice text results. But you can also get the numeric values if you add just 2 arguments to the fetch survey function. If you add this label equals false and convert equals false arguments, you will be able to get just numeric values. This is a tiny thing, but I think it's worth noting because some people may need to get the data in kind of a numeric format. So after you've made the determination between about how your data should be downloaded from Qualtrics, we're all set to move on to the final step, which is kind of the data preparation. So if you have existing import definitions for Qualtrics or other surveys, you might well know that you have to manually label some of the variables in your data frame with the word skip to tell Lava to skip reading those variables. So the code that I've written out here, this kind of rename at function, is a shortcut to rename any variables that need to have this skip label added. And you can use this code pretty much as is. All you would need to do is add the names of the variables that you want to rename inside of this vars function. So you'd delete the ... and you'd write, var, var1, comma, var2, comma, var3, whichever variables that need to have skip colon added at the beginning of their name. And please feel free to copy this code. This is exactly what you would need to kind of add the skip value. So once you've done that, You may find that there are some other data cleaning tasks that need to be completed. Again, if you feel like you have the capabilities or more kind of intermediate skills in R, doing your data cleaning directly within the script would definitely be my recommendation. And then finally, once your kind of data is done being processed and you're all set with it, you'll want to turn that file into a CSV and then upload it through Lava. So what you can use is this write_CSV function, and you'll need to specify a path or just a path argument, which is just where the data frame is going to be output. And in this case, for temporary files, I generally just write them to my desktop. So you can see that I've written this tilde/desktop and then the name of the file .csv. And the other argument here is NA equals, and I put colon, or sorry, not colon, but NA equals basically this blank space. And that means that any sort of missing values will just be filled in as blank spaces rather than writing out the word NA, which is the default behavior. I don't like that default behavior, so I tend to kind of write over it using this argument call. If you don't already have import definitions set up in Lava, then you'd want to work with the MacTac team to figure out if you actually need one and how you can get one set up. But when setting up, I would recommend that you don't create an import definition that requires using skip labels, because it's really an error-prone process if you ever end up doing it manually. And I do think it's easier to just say that, we're going to upload this data frame with these variables, and there's going to be nothing that needs to be skipped. So after you've made an import definition, you can return to the steps from the previous slide. And with that, I think it's, again, easier to kind of demonstrate all of these steps in action. So in this case, we're going to run that fetch survey function again. And the first thing I'm going to do is rename some of the variables. So I'm running this rename app, and I'm writing vars to pick which variables I want to rename. In this case, I've selected the end date variable, and I've also added the IP address variable because those are values that I just don't really care about, but maybe the Lava import definition expects them to be present. From there, you want to write out the remaining portion of the function that I had written out previously. And as you see, I run it, and those columns have been renamed, just as we would expect. So if there are also variables in this data frame that you don't want to have, I recommend using the select function. So you can write this out, and you want to write select and then -c and then the name of any variables that you want to get rid of. So again, we can run this function, and we see that the status variable is now gone from our data frame, just like that. And then finally, I'd also recommended that if at all possible, try to perform some of your data filtering tasks directly within R if you feel comfortable doing that. In this case, I'm going to use the filter function from the dplyr package to filter out or only accept observations where the finished variable is equal to true, or observations or rows where people actually finished completing the survey. And you'll see that I highlighted that the data frame is now 16 by 31, which means we lost a bunch of observations because people didn't complete it. And the final step in this process is obviously extracting your data from R. So like I said, you want to probably write this to a CSV format, which is why you can pull in this write_CSV function. And as I had mentioned, I tend to write things to my desktop. So we have this, I've specified the path location as desktop, and then my kind of Qualtrics file .csv, and I set the NA equals quote, quote, to keep the missing values empty. So just like that, I now have this set of data on my desktop, and it's everything that I had pulled from Qualtrics all kind of done and cleaned in just 5 lines of code. You'll see that the variables that I renamed to have the skip value do in fact say skip in the output of this. So it's basically the exact kind of data frame output that I would want, and it's pretty much all set to go into Lava at this point. So with that, that was really a quick tutorial on how to kind of accomplish this process. A couple of things I would want to note. is that you want to make sure the survey you're trying to get data from is not closed. And if for some reason you aren't able to authenticate your account, that very first Qualtrics package function that we ran, if that doesn't work, you might want to email qualtrics@ucsf.edu to make sure that your account actually is allowed to access the API. It's kind of hit or miss whether or not people will be given that access by default. So that's always a good thing to check in case the authentication process doesn't work out. But other than that, I'm more than happy to answer questions if there are any. But otherwise, I hope that this video serves as good reference material should you want to automate even part of your Qualtrics to Lava data processing.